Okay, this is passage 6, and we are. I'm just going to briefly give it a little overview, just to get my bearings. We have a table here, study 1, then we've got figure 1, and it actually goes on to the second page. We've got study 2, that's 3 bar graphs. I'm going to read a little bit of introduction just to find out roughly what it's about. It says 3 spine sticklebacks are fish that can live in marine, saltwater or freshwater environments. Marine sticklebacks and freshwater sticklebacks have plates, bony scales that provide protection from predators such as fish and birds. However, due to the low number of these predators in freshwater environments, freshwater sticklebacks typically have fewer plates than do marine sticklebacks. The ADA gene regulates the plate formation and has 2 alleles, capital E and little e. Table 1 describes the phenotype associated with each EDA genotype. And then we've got big E's, little e's. Okay, please do not worry if you don't understand any of that. I don't understand very much of it at all. I don't remember much of it, biology and genes and everything. But I promise you, you don't need to know anything about this biology to be able to get every single question in this passage right, and that's true for just about every passage you will ever have. Do not worry, do not concern yourself if you don't understand it. Let's get straight into the questions, and I'm going to prove to you that you don't have to understand it to get every single one of them right. Right, number 30. One of the offspring collected during study 1. Okay, so the first thing we're going to do is find study 1. In June 2007 had 7 plates. According to table 1, all right, so that's part of step 1, we have to find study 1. Table 1, this fish had which phenotype and which genotype? So 3 will be find the genotype, step 4 will be find the genotype. All right, so study 1 is here and table 1 is here. We've done step 1. Had 7 plates. So we'll look in the description here, and it has 0 to 9 plates, so that's going to be where 7 plates will be found. So I've done step 2, which was to find where 7 plates are. Step 3 is what's the phenotype? Phenotype is low. Step 4, what's the genotype? Little e. We just look for the answer choice that has low as the phenotype and little e's as the genotype, and we find that here and here. The answer is G. 31. Which of the offspring listed below were collected in study 1? Okay, study 1. Then I'll look at the first thing to do when it gives you a list of these things is to look at those and then try and find them somewhere in the study, in the graph, somewhere. It doesn't appear in table 1 anywhere. So in study 1, all right, I'm just going to scan it for juveniles, adults that were breeding. 200 marine genotype tagged and placed in freshwater during their breeding season. At the beginning of each month, from September 2006 to July, the offspring were collected and their genotypes were determined. Figure 1 shows the fraction of collected offspring with a particular genotype for each month, as well as the developmental stages of the offspring during the study. All right, let me look at the study. So this is the fraction of the collected offspring, and here we see it here. We have juvenile, so I'm just matching what it says in the question to the graph here. It has adult, and it also has breeding adults, and I think it's safe to assume that this would be non-breeding adults, and then these become in breeding season breeding adults. So basically it has juveniles, it has the adults when they're breeding, because that's here, and then adults when they're not breeding, that's here. It's all 3, that's D. One of the offspring measured in study 2, that's going to be step 1, 62 millimeters, step 2. In length, based on the results of the study, was the genotype of this fish. Step 3 is to find what the genotype was. Okay, let's go to study 2. And So we've found study 2, we've done that part. 62 millimeters, where are millimeters? We see it's along the bottom. And up here we have the different genotypes. That's 2 small e's, E and E, and capital E and capital E. It's just asking us to look at the capital E's and the small e's. So we're just looking at this one and this one. And then we're looking at 62 millimeters. This is 60 to 64. There are none. Absolutely none. Here, there are some. So it would be the small e's. And so F and G are gone because they said big E's. So H says because on average the E offspring were shorter than the EE offspring. Well, no. I mean, you can see here the small E offspring are all at 45 plus. Up here, the capital E offspring are all short. They're all from 30 to 60. So that's wrong as well. G is the small e's because on average the E offspring were longer. Yes, they were. It's G. Okay, so next question 33. According to the results of study 2, study 2, so that'll be step 1, find that. Sexually mature offspring, step 2, find that. Were collected in May 2007. The greatest number had which of the 3 genotypes? That's step 3. Step 1, study 2, right there. Step 2 of sexually mature offspring. What are sexually mature? We look at this key here, we see sexually mature is the dark box. Had the greatest number. Alright, so we just have to see, okay, these are the genotypes. So number 1 is capital E. It has this many, which is about 1. So that's out. This one is big E, little e. It has, let me see, that's about 1. This is about 4. This, and I'm just reading it across here, right? This is about 2, so this is about 7. Down here with the small e's, we have here, it's about 2. This one is about 6 tall, and this is about exactly 4, so this is about 12 collected. So the greatest number of the 3 genotypes was the little e, C. Okay. Oh, why does that C move? Stop. Don't move. Oh, it's jumping all over the place. 34. A researcher predicted, okay, that moving a marine stickleback population to freshwater, would result in an increase in the fraction of offspring with the low phenotype. Do the results of study 1 support this prediction? So study 1, step 1 is to find that. I actually have to go up the page here. And then he's saying that the marine sticklebacks going to freshwater would increase the fraction of thing. So study 1 says the 200 adult marine sticklebacks, we read this earlier on, and then we're put in freshwater. So this is the right test. This is the offspring collected, this FCO right here. And what he's saying is moving the marine sticklebacks to freshwater, like they did, would increase the fraction of offspring. So the offspring would go from low when they were added in September to high. So we're looking for the graph, the numbers to go up. So 1 was to find that study. 2 was to offspring with the low phenotype. All right, so I think that's step 3. What's the low phenotype? And you can see here on table 1, phenotype low is EE. And we go to the key here and we see that EE is the little triangles. So we look over here and we see that's the bottom line here. It starts here, which I would say is about 0.21. And then by the end, it's up here. And if I take that across, it's about 0.3, I don't know, maybe about 0.3, it ends about 0.35 or something. Okay, so it starts at 0.21, it goes up to 0.35, so they do increase. So his prediction is correct. So we can get rid of anything that says, no, the study doesn't support it, because it does. So H and J are gone. So now we just have to find the right reason. F, because the offspring for the low phenotype was about 0.13 greater in July 2007 as it was in September at the beginning, or it was 0.18. Okay, so Luft was about, so we're just looking at the numbers. I kind of clocked it at 35 minus 21. It was 21 at the beginning, it ended at 35. So that's about 14. So that's going to be closer to F. All right, and now we have the last question. In study 1, the most likely reason the marine sticklebacks that were placed in the pond were tagged was to ensure that. Okay, so study 1, first step, what was the likely reason that they were tagged? All right, study 1, 200 adult marine sticklebacks with the EDA genotype EE were tagged and placed in an artificial freshwater pond, and then the offspring. So the point was they collected the offspring. They put in adults and then they collected the offspring. So if you're collecting the offspring, you need to be able to separate the offspring from the adults. That's all you're trying to do, right? Because they collected offspring with different genotypes. The genotype doesn't matter. They have all different kind of genotypes. So let me see. The length, go to the answers. The length of each stickleback could be measured. No, that's got nothing to do with it. Parents could be differentiated from the offspring. Yeah, that's right. The number of plates on each stickleback could be counted. It's got nothing to do with the plates. Offspring collected could be genotyped only once. No. So it's B. They had to be able to separate out the offspring from the adults because they were the whole test is about the offspring that were collected. So it's answer B.